with a plus or minus sign, which tells me that there could be a certain amount of generated energy that could reduce the thermal energy of the system, or there could be a portion of energy generated which would increase the thermal energy of the system. I could have an endothermic chemical reaction within the control volume. What's that going to do? It's going to cool the system. That's going to reduce its thermal energy. I could have a nuclear reaction within the control volume. That's going to increase its thermal energy. Right? So that is the E dot generated term. So this is generated energy. E dot stored is the rate of change of the total mechanical and thermal energy. Okay, so this is mechanical and internal thermal energy, which, as you know, can be broken up into the sensible component and the latent component. Sensible component due to the temperature, latent component due to changes in phase. Take all of these quantities. So instead of E dot CV, E dot stored plus or minus E dot generated. Instead of Q net, Q in minus Q out. Minus W out, W in. The left hand side, I can write it as the following. Q in, watch this, negative sign, takes this negative sign, makes it a positive. So that's going to be W in positive minus W out plus Q out. All I'm doing is taking these equations and rearranging the furniture in the room. That's all I'm doing. Okay? And now I'm going to call Q in plus W in as E dot in, which is the net rate of change of input energy. Likewise, I'm going to have an E dot out. I'm not going to write it out. So Q out plus W out is E dot out. E dot in and E dot out are surface phenomena, which means they are taking place at the control surface. E dot stored and E dot generated are volumetric phenomena, which means that they are taking place as a function of the volume of the control volume. Okay, so these are surface phenomena. E dot generated and E dot stored are volumetric phenomena. And so if I combine everything together, and I'm going to do one more thing, I'm going to take this plus or minus Eg dot and bring it to the right hand side, I end up getting the following equation. E dot stored, rate of change of the stored thermal and mechanical energy, is E dot in, which is Q in plus W in, E dot out, Q out plus W out, plus or minus E dot generated. Last few minutes, bear with me. Rate of change of the stored thermal and mechanical energy energy. And the obvious question is, when should I use plus E dot G? When should I use minus E dot G? Okay, so I'll write that out and then we'll get out of here. If there is anything that you want to take away from this course, just one equation you want to remember for the rest of your life, this guy. That's it. The whole course is nothing but taking that equation, writing it down during every lecture, and trying to understand the phenomenon. Okay? So if E dot G is positive, then this means the energy generated increases the thermal energy of the system. Example of this, exothermic reactions. Nuclear reactions. Maybe I can have energy supplied by means of electrical devices. That's also energy generated, right? Because electrical energy manifests itself in the form of heat and light. So it could be electrical energy. So if you see a problem where some of these are the sources of generation, then you put a plus E dot G. Minus E dot G, this reduces the stored thermal energy. The energy generation reduces the stored energy. We may have some examples of this as well. Endothermic reactions are the easiest to think of at this point in time. So an example of this is endothermic reactions. Please remember the four equations that we have seen. Conduction, steady state, one-dimensional conduction. Convection, heat transfer, H times delta T. Radiation heat transfer, which I wrote and then probably erased at some point here. And then the last equation. When we come on Wednesday, we will start solving problems. The whole lecture will be devoted to solving problems. I'll be posting my homework on Sunday night, this week, Sunday night. You may or may not be able to solve the problems as yet, but wait until Wednesday, it should be a piece of cake. Okay?